In this problem, we find a pair of negative charges, Q1 and Q2. Q1 has a value of 3.33 nanocoulombs, Q2 5.22. Both charges are negative. We're told the distance from Q1 to some point P is 0.255 meters, and we're asked to find the distance D2 from the point P to Q2. We're told that the electric field at point P is equal to 0. Well, where does that electric field come from? We know that the presence of Q1 over here on the left creates an electric field. A test charge placed at point P would feel a force to the left. And so there's some electric field here, E1, created by charge 1. Similarly, a negative charge here at Q2 creates an electric field component pulling this way. We'll label that field component E2. Now, the problem tells us that the electric field at point P is equal to 0. We'll call that the net electric field, which is the vector sum of E1 plus E2 is equal to 0. That means, in effect, that these two individual field components cancel out, or that the magnitude of E1 is equal to the magnitude of E2. We know, generally speaking, that the electric field created by some point charge is equal to the constant K times the charge divided by the distance squared. So in this case, we can say that K times Q1 divided by D1 squared must equal K Q2 divided by D2 squared. I'm going to cancel out these K's, which are the same on both sides. And I'm going to drop the exponents on the charges because those will cancel out as well. And by solving what's left of this equation, we see that D2 squared is equal to D1 squared multiplied by, that should be a 2, by Q2 divided by Q1. And in the text below the video, I'll fill in some numbers and we'll get an actual answer for the distance D2.